In my last video, I said that VLANs are not security, and that raises a fair question. What are VLANs then? If you misunderstand this, your entire network design will be flawed. So today, let's clear this up and make it simple. VLANs are one of the first concepts that we learned in IT networking. They're everywhere, access switches, wireless, and in data centers, but they're often misunderstood in what they do and what their actual purpose is. So let's separate what VLANs are designed to do from what they're not supposed to do. VLANs limit and separate your broadcast domain. That means that devices will only hear the broadcast messages within their own local network, which is the VLAN that they're in. And this reduces unnecessary traffic. Let's say you have 2,000 devices and they all come online at the same time, and they're all going to the same exact place, the DHCP server. What's going to happen? All 2,000 will send out a DHCP request and it will be rebroadcasted to every single device. And that will start causing massive issues, and you might have clients complaining about no network connectivity, and they will have a 169 address. 169 address is an APIPA address that will show up if you do not get any address assigned to you, statically or from the DHCP server. But let me stay focused, we're not talking about that right now. Framing this for the real world, for us as network engineers, this is for scalability and efficiency. And these are security zones, but they are not technically going to be security by default. And talking about network scalability, flat networks don't scale at all. Flat networks cause many issues. And what can happen is you apply policies to a flat network that you typically apply to networks that maybe have 10, 15, or 20 VLANs, and you might cause issues. Let's just say, for example, you have DHCP snooping, and you forget to trust a certain port, and you forget to apply certain settings because this network is flat. You're going to cause some issues within that network, because if you don't trust the proper ports on that, where the DHCP server lives, or where your router lives, or another switch, you're going to have a lot of issues on that network. But if you're only going to do snooping on your enterprise network, this makes it a lot easier, because now your switches are not inherently going to be connected over that if you have a management VLAN. Broadcast traffic grows really fast, so making sure that all of your networks are small and have a very specific purpose is a really good idea. And VLANs allow you to grow without all the chaos surrounding a flat network. And this is why VLANs are mandatory in large enterprise environments. They provide logical organization. VLANs will be grouped by device function. You'll have cameras, servers, access points, enterprise clients, industrial clients. You might have a certain line of machines at work, and you group all of those on their own VLAN as well. And this makes networks easier to understand and makes troubleshooting a lot easier. It will organize your security policies. You'll have a policy for each VLAN, and you apply that on top of the VLAN at the firewall. And this makes troubleshooting a lot easier as well. Let's say you're having an issue and the guy says it's from this machine line. It's one of the CNC line in the factory. And you now understand it's with this line. I go out there and you realize that it's on a computer that is on the industrial network. And in that industrial network, you hear some other people complaining about the same issue. Now you know that it's something with those computers, or it's something with that VLAN. And that could be a security policy. It could be broadcast traffic that's causing issues. Now you're going to be narrowed down to a certain VLAN, and it's only going to be affecting that one. If you had a flat network, that one device having an issue could cause your entire network to go down and could cause your switches to stop passing frames. And these are a few things that VLANs do not do. VLANs do not inspect traffic. VLANs do not block routing, and they do not enforce security policies. They are not a firewall, and they have no access control mechanisms by default. And VLANs do not prevent inter-VLAN communication. By most default standards, your layer 3 device is going to pass traffic no matter what to any device that it wants to. You have to go in and do a zero trust policy, which is a great policy to apply, and only open up things that are needed. So if you need just Outlook for a certain network, boom, only Outlook. If you need PCs in this VLAN to get to this server, make that one exception. Doing it this way is going to keep your network very secure. But you're doing this on the firewall, and you're not doing this actually on a VLAN or in the layer 2 realm. Key takeaway here is that if traffic can be routed, it'll be able to communicate to anything until you tell it not to. VLANs are your foundation of your network and your IT infrastructure. They create real structure, and they create a real world stack of VLANs, routing, policy, and your security. Examples, you could have a VLAN and you have ACLs applied to that VLAN. You have your VLANs and you have your firewalls. You have VLANs and you have zero trust segmentation, which is what we were talking about earlier, and not allowing anything to talk to each other by default. The key takeaway here is that VLANs, especially in the enterprise network, make security possible. They don't create it by just adding a layer 2 tag. Some common mistakes to avoid when it comes to VLANs. You need to make sure that you plan ahead. Make a big plan, have a nice spreadsheet, or don't just write something on paper and hope it's going to work. You need to plan out your network, and you need to plan very well. You need to understand the scale of your business, and you need to understand what is going to be coming down the line. And when I say this, it means that you need to plan out your enterprise VLANs, your access point, your network management stuff, and you need to make sure they are not close together if you want to keep a good scheme going. You need to stay in the certain ranges. So for example, maybe your enterprise will be 1 through 100, and that will be all of your user facing networks. Like your APs will be in here, your management will be in here, your enterprise networks, maybe your cameras. You keep stuff like this tied together, and then you have your industrial network, which might be 100 through 200, and this allows you to understand this by seeing the VLAN tag or the IP address on what network you're touching at that moment. Over segmenting without a purpose is also a major issue. Earlier we talked about if you have the same machine and if you have the same style machines, just put them all in the same VLAN. If you're a very small shop, it might make sense to not do this. It might make sense to keep one VLAN just for your industrial and poke to certain holes from an IP to an IP. This is a very small scale. This has no scalability and is very small. But if you're a small company, you're not going to need enterprise planning for this. However, if you are a larger company and you have hundreds of thousands of devices, you do not want to be making exceptions in the firewall per IP for 1,000 different devices. That's just unscalable. This is why you group everything into a VLAN and you apply policy to that VLAN. And in summary here, VLANs separate your broadcast traffic, they improve your scalability, and they organize your networks with logic. VLANs do not secure the traffic, they do not enforce any policy, and they are not a replacement for firewalls. VLANs are a foundation, they are not your main security controls. Please be sure to subscribe and hit that like button. In the next topic, we'll look into how VLANs and routing work together to create the internet.